All right, this problem is, or we are focusing on this question here. If you can see it from Schoology, dealing with the mass of gold 1 permanganate. Help if I do that? No, not really. Sorry, it's my first time trying to do it like this. Nope, it just stays glared. Anyways, you can see what that is. So let's take a look. This is kind of like the very last problem that you had to watch on video from the solubility and net ionic lecture. But the question is asking, it wants to know what mass of gold 1 permanganate, all right, is going to be formed from a reaction. All right, and then it gives us some of the things of the reaction. So it says that we're going to be mixing, we're going to be creating it from a mixture of gold 1 oxide. All right, so we're going to be, it says, mixing gold 1 oxide, which looks like that, with beryllium permanganate in a beryllium permanganate solution. So let's get beryllium permanganate also. All right, so there's the solutions that are being mixed together. Like we did in class, this will be double replacement. So the gold and the beryllium are going to switch places. All right, so when that happens, beryllium will be with oxygen. All right, it's +2, -2. That's why no subscripts will drop. And over here, by the way, beryllium was +2 and permanganate was -1. So that's what made the 2 appear. And gold will now be with permanganate, which exactly we knew it was going to be because that is the product that we are analyzing. All right. We're not balanced, so it looks like my golds are incorrect. And now that actually balances the whole thing. All right, so now let's take a look at the information that it gives us. It says that our gold 1 oxide here is going to have 0.35 molar, all right? And I'm going to set that equal to the amount of it, which is 45 milliliters. So I'm going to put that over 0.045 liters. So in case you missed why I'm setting it up like that, remember our molarity equation is moles over liters, all right? So it gave me molarity, and it gave me milliliters, all right? It said 45 milliliters, all right? But I can't use milliliters, so I slid the decimal to the left 3 times and created 0.045 liters, all right? And this will give us moles of the gold 1 oxide. Now, think about what I'm doing here, though, because the other information that it gives me is the setup for beryllium permanganate. So really, it's kind of like a limiting reactant problem because it's giving me amounts of both reactant, and it's wanting to know how many grams of the gold permanganate is going to be made. So only one of these can determine the amount of cake that we make over here. So I need to figure out which one of these dudes is going to yield less product theoretically. So I'm going to set up beryllium also. So if we look back to the problem, it says that the beryllium permanganate exists at 0.19 molar. All right. So I'm just going to kind of, just so we don't get it mixed up. So we've got 0.19 molar. All right. And the amount of milliliters we have is 75. Again, we don't want milliliters. So we're going to turn that into 0.75 liters. And now we can solve for x on both of these, all right? You can put the molarity over the whole number 1 and cross multiply or whatever. And when I type that into the calculator, I'm going to see that my mole count for the AU2O is going to equal 0.158 moles. And my mole count over here for beryllium permanganate, all right, when I solve for X there, is going to give me 0.0143 moles. Now, the only way I can compare these numbers is if I take these coefficients from the balanced equation into account, because there would need to be a mole over mole step. However, they're both 1. And since they're both 1, I can rely solely on these two values to figure out who the limiting reactant is. Of course, the smaller number wins. Therefore, this is not going to matter. It's going to be just the moles of beryllium permanganate that will overall determine the grams of my product. All right, so now we can run a stoichiometric grid in order to figure it out. So we've got moles of given. So from moles of given, we can go to moles of unknown. So we're going to go to moles of Au2MnO4. All right, of course, the diagonals need to match. So let's bring down the letters. And this would give us moles of the answer that we're looking for. However, we don't want moles, we want grams. So from moles of the unknown, we can go directly to grams of him. Make the diagonal match. All right, and now we can set our stuff up. So we've got moles over moles, which we know is always coefficients. The coefficient of the gold permanganate is 2. The coefficient of the beryllium permanganate is 1. When grams is over moles, or when they're being compared rather, it's always 1 mole equals periodic table grams. Therefore, we need the molar mass of the gold 1 permanganate. So we can easily add that up by saying, all right, well, gold is 196.97. Permanganate is 54.94. And then there's 4 oxygens, so plus 16 times 4. And I'm going to get a molar mass of, oh, did I multiply up in there? We didn't want to multiply. Oh, I don't want to type it all again. Dang it, 196.97. Yeah, don't mix up your operations or it'll give you some funky stuff. Right here I put multiply plus 16 times 4. There we go. Hey, look, a number, 315.91. All right, and now we can run the grid, which is going to say that 0.0143 times 2 times 315.91 divided by 1 times 1 is going to give me a final sig fig answer of 9.04 grams.